Okay, sir, I will start the session. Hello. Hello, sir. Sir, can you hear me? Hello. Hello, sir. Hello, sir. Hello, sir. Can you hear me?
Hello, madam.
Okay, sir. I will start the session.
No participants, madam.
Yeah, they are coming on the way.
No, you can put reminder in WhatsApp group, madam. No reminder.
Yeah, already messaged. Okay, sir. So good morning to Dr. Jason Somasekar, and good morning to the participants we are watching this live session. Welcome to the applications and case studies of machine learning session. In this session, we will explore the fascinating world of machine learning and dive to the practical applications and real-world case studies that demonstrate its power and versatility. Machine learning has revolutionized various industries and domains, enabling us to make data-driven decisions, automate process, and uncover valuable insights from complex data sets. So, we encourage active participants curiosity and collaboration throughout the session. Feel free to ask questions, share your thoughts, and engage in discussions with your fellow participants. Before we start Dr. J. Somasekar session, I would like to give some short introduction about the Dr. J. Somasekar. So, ladies and gentlemen, it's my pleasure to introduce our esteemed guest speaker for today's session on applications and case studies of machine learning. We are honored to have Dr. J. Somasekar with us, who brings a wealth of knowledge and experience in the field of machine learning and its practical implementation. Dr. J. Somasekar received a PhD degree in computer science and engineering from JNDUA, Andhra Pradesh, and M.Tech degree from the National Institute of Technology, Karnataka, Surathkal. And he is currently working as a professor at the Department of Computer Science and Engineering, Faculty of Engineering and Technology, Jain University, Global Campus, Kanakpura, Bangalore. He is also a postdoctoral researcher at University of South Florida, USA. As a research person, he has delivered 145 technical talks for AICTE, ISTCTE workshops, webinars in 12 states of the country, and keynote speaker for 7 international events. Currently, he is gaining 6 PhD research scholars in the CSE department. He is also received the Innovative Collaboration Researcher Award in Medical Imaging for research collaboration with Dr. Ching Gong Lai, Director ITRI, Taiwan by WRC in association with United Medical Council. At the end, I would like to introduce to the motto of Dr. J. Somasekar. His mission is life to create a master shaping today's youth and tomorrow's leaders. I would like to hand over the session to Dr. J. Somasekar and also thanks a lot for joining us today, Dr. J. Somasekar, and over to you, sir. So, sir, you start the session now.
Yeah, thank you for introduction, madam. Now I will share my PPTs. Are you able to see my full screen, madam?
Ah, yes, sir.
Okay. So good morning, all the participants. So thank you for your introduction and opportunity, madam. So welcome to the skill development session on applications and case studies of machine learning. So today we are going to discuss about briefly what is machine learning and what are the applications and what are the case studies comes under machine learning. It's very difficult to cover all the case studies within 1 hour session, but I'll try to brief out all the case studies. Most of the important case studies. So based on that, we can understand the significance of machine learning in the present scenario and why this much importance for machine learning nowadays. All those things you can understand in detail once session ending up. So now, before going to the basic concepts of machine learning applications, all those things. So what are the case studies that we are going to discuss? I will briefly show the idea. Then based on that, we'll go for further in detailed explanation about all those case studies. So one first case study is healthcare applications. So by using machine learning, how to classify the patient data like disease or not disease. That means we have to classify a person having disease or no disease like that. So that we'll discuss. For example, here I'm going to explain on COVID-19. Whenever if we collect information, that means symptoms, or we can call it as a technically features from the patient. So whatever symptoms from the patients, if we collect based on that, we can classify the person having COVID positive or COVID negative. That is one a simple classification problem. That is one of the important application of machine learning. So that is called healthy care that we'll discuss. And what classifiers we have to apply that we'll discuss in detail when you enter into the rest of the session. And email spam filtering. Every day we are receiving some mails. So some mails will go to the spam folder and some mail will go to the inbox. Inbox means not spam, or we can call it as a ham, H-A-M. So a mail can be classified as a spam or ham. So how it will classify? So what are the mails? It will go to the spam folder, and what are the mails will come to the inbox or not spam or ham folder. I hear how machine learning plays a vital role that we will discuss. This is one of the cyber security application that is called cyber terrorism. Email fraud is a cyber terrorism. So that we are going to catch by using machine learning algorithms classifiers. By using that, we can classify easily whatever mail we have received, that is spam or not spam. That also we'll discuss. And one more very important case study, of course, application of machine learning that we will see use case or case study, that is called recommendation system. So every day we are being influenced with this recommendation system. Whenever if you open YouTube or maybe e-commerce websites like eBay or what we can call it as a Amazon, etc. Just a minute. Session loan ಅಲ್ಲ ಜಾಸ್ತಿ ಕೊಡಿ. So whenever you go for any e-commerce websites like Amazon or eBay,
Hello, sir. Sorry
hello,
for the
madam.
interruption.
Hello, madam.
Sir, your screen is not able to see here.
Visible, madam. Just I'll stop again and share. Is it visible, madam?
Yes, sir. Everything's fine. Okay.
Okay, fine. I don't know because when I started the session, it was visible. Fine. So one more important use case or case study that is called a recommendation system. Whenever if you open YouTube or maybe streaming services like Amazon Prime or maybe Sun Next, etc. So we'll get some recommendation of the movies or some videos. It can be comedy videos or web series or some music, etc. Even when you go for e-commerce websites, also Amazon, eBay, etc., you'll get recommendation of the products. Exactly what is happening beyond it. Not only like that, even when you open Facebook, like recommendation of the friends, or when you open LinkedIn you'll get recommendation of the connection. So exactly what is happening beyond that, so there how machine learning plays a vital role. So that is called machine learning for recommendation system. It may be product recommendation, or it may be movie recommendation, or it may be social media recommendation, whatever it may be. Exactly how machine learning plays a vital role, that also we'll discuss in detail as one of the case study of machine learning. This is one of the more powerful case study of machine learning, because there is a huge income is generating because of this recommendation system, because almost all the sectors we have this recommendation system. So that also we'll discuss in detail. In general, just for recommendation system only I used to take more than 2 hours, but here I will try to precise, and based on that I'll try to explain the concept along with small case study of this recommendation system, so that we can understand how the recommendation system works and how machine learning plays a vital role for this recommendation system. And this we'll discuss later. Of course, here because of recommendation system, the revenue also increased 35% of the Amazon, and also 75% of the users are watching movies in Netflix because of this recommendation. So these are the recommendation system facts. And also one more case study what we are going to discuss, that is called intrusion detection system. This comes under machine learning, cyber security. How machine learning plays a vital role for cyber security. There, this is one of the application. So how to use machine learning algorithm for detection of intrusion, or we can call it as a classification of the cyber attack. So we have various types of attacks, that how to classify, that we'll discuss. So intrusion means unauthorized access. So some third person trying to access the network or maybe system, etc. How to detect whether the person is maybe what type of um, error is trying to inject to our system or maybe network, so that we are going to classify. If the whatever information we are receiving through networks, if it's good, then there is no issue. If something is injected, then there is a harm for the network or maybe organization. Because of that reason, machine learning comes to the picture, and it will plays a vital role for this intrusion detection system. As per the statistics, more than 80% of the companies are going to use machine learning for detecting viruses or detecting unnecessary threats by 2025. Now also some of the companies are already using machine learning. By 2025, as per the Capgemini report, more than 80% of the companies are going to use machine learning. Because of that reason only, there is a huge demand for machine learning specialist or data science specialist, because of these many applications we have in the real world. Even this is also one of the healthcare application that I have already shown for COVID-19. In similar way, here we have to classify whenever if we have collected symptoms from the patients like headache, runny nose, fever, etc. Whatever it may be symptoms. Here I'm showing just for test, I mean sample symptoms. Maybe we have more than symptoms also possible. In that case, based on the symptoms, how we are going to classify the person having flu or not. So that is one of the healthcare application that also we'll discuss. And even here recommendation of the what we can call it as a prescription. So for example, I have a fever, I have a prescription like this dolo 650 we have to take morning, afternoon, like that. Or maybe I have some other disease, so I have prescription. Or maybe I have some other disease, I have prescription. So suppose one similar patient having same symptoms or disease, then what type of prescription we are going to recommend to the patients. So there also recommendation system comes to the picture, and machine learning plays a vital role for this recommendation of the prescription to the active patient. Active patient is new patient whenever the person coming for testing. Or maybe if we have an app of this recommendation system, system, directly we can enter the symptoms of the patient and automatically we get this is the prescription recommending for you. Then you can go to the pharmacy and you can buy the tablets, or maybe through online also you can give order. Because of that reason, you can save the time, you can save the energy, money, all those things. So that is very very important application of this machine learning as a recommendation for healthcare sector, not only for movie product recommendation what we have discussed briefly about previous slide. And this is the prescription recommendation. And even when you come to the one more important forecasting or prediction, etc. Maybe I want to predict the rainfall forecast maybe tomorrow or maybe next month, or maybe I have to predict country's GDP of next year, or I want to predict how many students are going to pass, or I want to predict what is admission for XYZ branch in this year, or I want to predict number of COVID cases tomorrow, or I want to predict something else. So whenever if you are looking for prediction forecasting, there also machine learning comes to the picture. By using machine learning models, we can go for prediction or forecasting. So that is also very, very one of the important application case study. So these are the brief use cases or case studies that we are going to discuss in the uh, rest of the session, that we will see what type of classifiers or what type of machine learning models we are going to apply to get these details. I mean, get for these use cases. Based on that, we can understand. Of course, we have so many algorithms or so many machine learning models, so we don't have time to discuss all those things in this 60 minutes time. So just I'll give brief direct classifier. By using that, how we are going to apply to the various applications. That is, by using that, we can see what type of output we will get and how we are going to classify, or maybe how we are going to predict, or maybe forecast. So basically, we are focusing on supervised machine learning. Of course, so far we don't know what is supervised, unsupervised, etc. That we'll discuss in detail. So this is a brief case studies what we are going to discuss in the rest of the session. Just for overview, I have showed all the case studies. Now we will see one by one. And before going to that, we will see the basics of machine learning. After that, we will go for all the case studies one by one. At the end of the session, I will provide some of the references that we can utilize for further enhancement of the subject. Based on that, we can explore more about machine learning. Even I'll show data set, how to get data set or data set resources also. Based on that, we can download the data set, and according to application you can apply. So all those things will show at the time of resources. That is also very important. Because of that reason only, you can go for further enhancement of the subject. Now, first we will see what is machine learning. So, because without a definition, we can't directly move to the case studies. That's why we can go for initially basics. After that, we can move to the case studies of machine learning. So, whenever if I take a human, we can understand based on the experience. So, whatever it may be, I have learned based on the experience only. But whether is it possible machine can learn? Yes, machine also can learn based on the past data with the help of machine learning. Here, a past data, or we can call it as historical data, is very, very important. So without data, nothing to do with machine learning models. That's why, so data is nothing but a money nowadays. So everywhere we have huge data. Huge data is generating in all the organizations or all the companies, even academics also. So for that, machine learning comes to the picture. By using machine learning, we can go for get experience from the past data. Based on that, we can go for prediction of future data. So that's why data is very very important. By using that only, we can go for making a model followed by prediction or forecasting. So finally we can make a conclusion. So that's why, so machine also can learn from the past data with the help of machine learning algorithms or models. So that means, so data is very very important. So without data, nothing to do with machine learning. If you don't have any data set or data, machine learning models or deep learning models, all those things, there is no use. What is the use of applying these models without any data set? So that's why data set is very very important. Without data, machine cannot learn anything. That's why data is very very important. Now, based on this, so what is the definition of machine learning? It is a tool. It will extract pattern from the data. Based on that, we can go for prediction or classification. So what does it mean? So we have, for example, last 10 days data I have, let us assume rainfall data. So by using that data, that is called past data or historical data, I have to extract pattern from the data. I have to make one model. By using that, I can predict what is the rainfall tomorrow, or what is the rainfall after 10 days. Sorry, what is the rainfall after 1 month? Or I can go for prediction of a number of houses sales in Hyderabad or Bangalore, etc. But here data is the fuel that drives the machine learning engine. So this is a brief definition. So we have to look for pattern from the data. Data means try to understand that is a past data or historical data. By using that we can go for a prediction or classification. That we will see what is the meaning of these terms, prediction, classification. But data is the fuel that drives the machine learning engine. Without data, nothing to do with this machine learning. Just like a car without petrol or diesel, what is the use? There is no use. Like that here also, data is the main thing for machine learning algorithms. Now here, what is the meaning of extract knowledge or pattern from the data? What does it mean? For example, we have X, this is 1, let us assume Y. Maybe this is day, let us assume for better understanding, I am assuming this is day and this is rainfall. So this is a better simple example. So this is rainfall. Day one rainfall is, let us assume, 5 centimeters. Maybe day or date, whatever it may be, according to the application, we can assume that. And day two and rainfall is 7 centimeters. Day three, let us assume 8. So what is the rainfall in day four? We have to go for prediction or forecast. So now this is the data actually. So this is the data we have. Actual data is past data is nothing but this one. This is the past data or historical data. Now, by using this, we are looking for extract knowledge from this data or patterns from this data. So, by using machine learning model, maybe that is called linear regression, the pattern what we have extracted from the past data, but we don't know how to extract that. We will see by using a regression analysis. Suppose I extracted a data like this. So, 2x plus maybe 4. Let us assume like this. So, this is the pattern or knowledge extract from this data. By using this data, what we have to do, we have to classify the pattern from this data. Suppose I extracted a data like this. Pattern. By using that pattern, we can go for prediction of the future value. Suppose if I want to find what is the rainfall on day 5, just you can substitute the value of x as 5. So x is independent variable, y is dependent variable. This is a dependent, this is independent, because the value of x depends on y. That's why we can call it as a y is a dependent variable, x is a independent variable. So this is a simple example for this machine learning. So what we are doing, we are extracting knowledge from the data. Based on that, we are looking for some comment I got. Fine. So now I will go to one more simple example. I mean, for definition of machine learning, I will give one more classification. That is the forecast or prediction, rainfall or maybe COVID cases. When you come to the classification, this is the past data. So or historical data. We have patient one, patient two, like that 9 patients, and each patient having a features, or we can call it as a symptoms, like fever or maybe loss of motion, dry cough, or maybe diabetes, etc. Each patient having symptoms. So obviously we have class also, that is called output also available. Patient one COVID negative is having COVID negative, and he is having COVID positive result, and is COVID negative for this patient three, COVID four positive results. Like that, all the data we have. Suppose one new patient visited and he is having these features, chest pain, dry cough. What we have to do, we have to extract pattern from the data. We have to learn from this data, whatever historical data. Based on that, we can predict or we can classify the person he is having COVID positive or negative. So that is called classification problem. We have to classify based on the symptoms what we have received from the patient. That is called chest pain, dry cough, loss of speech, fever, etc. Shortness of breath. That is mentioned here. So based on that, we are going to classify the person having COVID positive or the person having COVID negative. This is called classification problem. Previous one is prediction or maybe forecasting. So both comes under supervised learning model, that we will discuss what is supervised learning and unsupervised, all those things. When it comes to the machine learning model, I already mentioned data is fuel that drives the machine learning engine. So we have a data. When you're looking for to learn from the data, we have to go for training data. So training, Let us assume we have to train the data, that is called, let us assume 80% training. Suppose if you have a data set of 10 records or maybe 10 rows, let us assume, in general, technically speaking, 10 data samples or 10 records. So 8 data samples or data records we can try consider for training phase, and rest of the 20% we can consider for testing, or maybe 70/30, depends on. So you can take 80/20 or 70/30 as a training data and testing data. By using training, so we have to extract knowledge from the data. So that is called training phase we can do. In testing phase, by using new data, whatever data we have in the testing data set, so we have to go for test data. So there we have to evaluate the accuracy. So based on the accuracy, we can decide whether the model is suitable to the given application or not. If the evaluation of the data accuracy is very less, then we can look for alternative model for prediction or maybe classification. If the accuracy is very good, no need to go for alternation, then we can apply the same model for prediction or forecasting or classification. So that means depends on the application. You can take 80/20 or 70/30 as a training data and test data. But accuracy, for that we have to use evaluation measures. That is very, very important. So whenever if I take even semester students also, all the students will attend classes, and obviously how we are going to evaluate by conducting exam. Same thing here also. So we have various evaluation measures, depends on the problem. So by using the evaluation measures, we can decide whether the model what we have applied to the given data set is over accurate or not. If more accurate, fine. Otherwise, if we have to go for alternative, or maybe we can go for fine tuning of the parameters based on that to get the better accuracy. So this is called machine learning model. And we have classification problem. Classification means we have a group of people, let us assume class. We have to classify boys separate, girls separate. So categorizing the students as a boys and girls, or maybe categorizing the data into various clusters, various groups, that is called classification. So whatever data we have received, we have to classify whether the data is COVID positive or COVID negative, or maybe fever or not fever, or maybe malaria fever or dengue fever. Like that, we can do more than one classification also. More than one classification is, if you have binary classification, the result is yes or no. If you have categorical classification, then the result is A, B, C, D, like that. If we take a student marks, what are the possibility of student grade? A grade possible, B grade possible, C grade possible, D grade possible. These we can call it as a categorical classification. Binary classification is pass or fail, yes or no. But whereas in categorical classification, we can go for more than two classification. So not for same data. For any data sample, we can classify only one, either true or false, or maybe A or B or C, like that. We can't make A comma B true comma false, like that. So the output is always unique. That means final the result is unique. So we can't go for two results. Like after your results in B or maybe whatever it may be exam, either pass or fail. We can't say pass and fail, like that. So that's why always the output is unique. So in categorical, you will get more than two. Whereas in binary, we can go for exactly two, yes or no, like kind of thing, like COVID positive or COVID negative. So that is called classification problem. We have supervised learning and unsupervised learning. I'll explain in detail through uh, diagram so that we can understand better what is exactly supervised, what is exactly unsupervised. Here, supervised means we have a labeled data. You can see x1, x2, and we have last column is nothing but class or label, or maybe output. We can call it as a y. Let us assume. So the f of x1, let us assume x2 leads to y. So each x1, x2 value we have output. Whereas in unsupervised learning model, there is no label here. As you can see here, so there is no label here. So, but still we are looking for a classification by using various clustering techniques, etc., or maybe association mining, or it may be clustering, or it may be something else. So based on the applications, we can go for, even we have that is called a query algorithm is there for association rule mining. So that is called unsupervised. But anyhow, we are not going to focus for this unsupervised learning model. We are focusing only for supervised learning model. That means we have input as well as output. And when you are looking for future data, just we have to go for classification. And when you come to the semi-supervised learning model, it's a combination of labeled data and unlabeled data. Some of the data having labels, some of the data not having label, that is called unlabeled data. Whereas if you have a label, that is called labeled data. Supervised learning model is 100% labeled data. That means each student having result, either pass or fail, or A or B grade like that. Whereas an unsupervised learning model, there is no result. Student marks we have, like 6 subject marks we have, but output we don't know. Whereas in semi-supervised, some students having grade, some students not having grade. So that is called semi-supervised learning model. So these are the classification main types, and basically we are focusing for supervised learning model. We have labeled the data based on that how we are going to classify, or how we are going to predict, or how we are going to forecast. So this I have already explained, classification regression. So classification means we have to classify the data either true or false, or maybe disease or no disease, or mail is spam or not spam. Regression means the output is continuous value. So like what is the house price, or what is how many number of COVID cases, or what is the LAC premium money for next session, etc. So here output is nothing but, so it's a continuous value, numeric value, whereas in classification output is either binary or categorical classification. So we will see both a few case studies for various real world application problems. So what are the applications? Hope you understood clearly what is machine learning briefly. Machine learning is a tool to extract knowledge or pattern from the data. By using that, we can predict future, or we can go for classification. So how it is different from traditional programming. In traditional programming, we can write program explicitly, whereas in machine learning, we can't write program explicitly. That's why it will come to the picture. And the data also huge data. And what are the machine learning models? What is classification? What are the types of classification problems? These are the, and what is machine learning model testing, training, data percentages. So now, what are the applications of machine learning? We can see you have huge number of applications. Almost all the sectors where we can use machine learning application. So here I have shown so many application. So because of that reason only, there is a huge demand for this machine learning specialists, or maybe experts, or data science experts, because of these many applications. So here I have shown so many applications. So huge requirement is there for specialist in machine learning data science because of these applications. So as you can see here, medical diagnosis, I already told you classification of the disease, either COVID positive or negative, that we will see, and stock market trading and online fraud detection. We have to go for this is machine learning for cyber security application, and virtual personal assistant, and email spam filtering. So whatever mail we have received, we have to classify the mail is spam or not spam. I already gave one small screenshot about this in the first second slide. And self-driving car and product recommendation, that also we'll discuss today, and traffic prediction. So this is also one of the major issue in most of the metropolitan cities. So further still people are trying to use different techniques, but still it is not work out properly because of huge crowd or maybe various other constraints. So in Bangalore also we have almost similar situation, traffic prediction, morning means too heavy traffic like that. So by using machine learning model, how to go for traffic prediction. Based on that, we can plan accordingly. Otherwise, if by mistake we come to the road 9 o'clock or 9:30, then obviously huge number of vehicles are moving towards the city. Obviously, even college buses, all those things. So because of that reason, the traffic is little bit high. But how to go for traffic prediction based on that? How to minimize the traveling time? That is also machine learning plays vital role. Speech recognition, image recognition. So here image classification also there by using CNN, etc. So, but anyhow, that is not scope of our today's session. So here I have shown so many case studies, applications for case studies. So like applications in healthcare means I have shown so many case studies initially, or maybe recommendation system or product recommendation system, etc. We can apply various machine learning models, but I'll try to show one simple model how to apply for these case studies data sets. Based on that you can understand, and similarly we can take decision tree or random forest or knn or maybe svm etc, whatever it may be, other regression models, or maybe you can make any novelty regression model that you can apply to the given data set. So that depends on the application. So just I'm showing to use, I'm going to use how the name based classifier is applicable to the case studies what I have shown initially. So before going to the apply the classifier, in general, the data set looks like this. As you can see here, we have, these are called data samples, data points. So R1, we can call it as a DBMS records, R1, R2, R3, R4. These are all records. I am assuming M records. And the X1, X2, X3, these are nothing but attributes or features, or we can call it as symptoms. So if we take a medical terminology, so these are in general we can call it as attributes, or fields we can call it as columns. So x1, x2, x3. So what is the meaning of attribute or I mean features means, if you take medical terminology, what are the x1 value, fever, x2 value, cough, like that. Or if we go for, or if you go for any other application, cyber security application, etc., maybe some other data is available. But this is the generic layout of the supervisor learning data set. So by using supervisor learning models, we can go for classification of the new data sample. So class is nothing but output, or we can call it as a label. So whatever data, suppose up to RM, we have a data points up to RM. M records are available. We can call it as a records or data points or data samples. Suppose I have a new record. Let us assume RM plus 1. So this is the new record. Now some data is available for X1, X2, Xn. Here data is not updated, but let us assume some data for x1, x2, x3. Now we have to assume some data x1, x2, x3. And by using this data, we have to classify whether the data comes under C2 or C1 class, maybe disease or not disease, like that depends on the application. So that is called supervised machine learning models. By using that, we are looking for classification. So here I'm taking binary classification C1, C2. If you are looking for categorical classification, instead of C1, C2, maybe you can have C1, C2, C3, C4. Maybe again it may repeat also. So categorical means you have freedom to choose the various classes. Whereas binary means always we have two classes, that is called yes or no. Now, basically, what I'm trying to do, so this is the healthcare data set. Let us assume, and I have a new patient data. By using that, we are going to classify, or we are going to predict the output or class. Now, what about base classifier? So, as you can see here, we have x1, x2. What is the model? I'll explain. X3. Let us assume these are the futures, and class R we can call it as a label. We can call it as a C. So we have a class or label that is called C. What are the features? We have X1, X2, X3, and class is C. Now, whenever if I take some new data, class, let us assume C1, C2, we have some data, whatever it may be. New data, what is the class? So I have to find what is the class. So I have to go for classification, whether C1 or C2, like that we have to do classification. That is the question mark. So for that, Bayesian classifier is simplified version. I'm writing directly formula, because if we are looking for intuition, it will take a lot of time. So I used to take 1.5 hour, 2 hours for intuition, then followed by a Bayesian classifier formula, but it is a very lengthy topic. Anyhow, directly we can go for the classifier formula. The in even exam point of view also sufficient, and that how we are going to apply to the various applications. Now, basically, what is the classifier formula here? So we have two classes. We have to find probability of C1 given X. X is nothing but symptoms. Whatever symptoms patient having, or maybe whatever features patient having, that we can consider. So this can be derived by, this can be written as, so P of X, that means the probability of the future, and this is called clear probability, and this is likelihood P of X given C1. P of X given C1 divided by, in general, denominator is not mandatory. Suppose if you want to extend denominator, P of X. So this is here summation, because we have to apply for all the classrooms, not only for one classroom, but in the first three toppers. We require all the classrooms toppers, then we can consolidate it, then we can decide these are the three toppers, then we can announce. Otherwise, if we take only from one person, that person is known to you, then it's a problem for the rest of the participants. It's injustice. Same thing here. So this we no need to consider. If you want to consider, we can make it as a p of x. So similarly, we have to find probability of c2 for class 2 given x, and same formula we can apply. So suppose here probability is 0.7 and here probability is 0.2, then which is the highest probability? 0.7. So argmax is nothing but c1. Therefore the final classification is c1. So this is the final. So now just we can apply the Bayesian classifier. Based on that, we can look for. That's why we can call it as a probabilistic classifier also. So we have to look for highest probability, and based on that, we can decide. So this journal is going to publish because of results are more. So whatever I have explained here, you can see the formula. So P of C1 given X, I given formula here, what I have shown. And we have to find the argmax. After finding C1, C2 probabilities, we have to look for, suppose this probabilities I have shown already, 0.4, and this probability is 0.9. So now we have to find maximum. Here you can see max. So maximum 0.9. What is argmax? The maximum value corresponding to which class? This belongs to which class? Argmax C2. So therefore we can classify the test data is classification is C2. So this we can make it as a C. So this is the test classification. That classification is nothing but. So this is the way we can apply Bayesian classifier for classification. What are the things we have to do? We have to find the probability of each class based on the symptoms of the patient or maybe features of X. And after that, we have to look for maximum probability, and that maximum probability corresponding to which class, that is called argmax. As you can see here, so without argmax, that is called just probabilities only. Argmax means we have to look for maximum probability corresponding to the class. So here, for example, probability of C2 given X having maximum probability, then what maximum is probability of C2 given X. Then what is argmax? The probability corresponding to which class? So maximum probability corresponding to C2 class. Therefore, argmax is nothing but C2. Therefore, output is C2. So that is the class we have, classification we have done based on the given data. Hope you can you understood this one. In general, we require intuition, but it will take a lot of time. That's why I'm showing directly Bayesian classifier formula. So basically, the classification process is we have a new data and we have to apply Bayes classifier, and we can go for class. So that is called label. Whatever data I have received, that is called new data X. Now I have to apply Bayesian classifier. After that, we can go for class, either true or false. Maybe the patient having COVID positive or the patient having COVID negative. That is the final class. If you have categorical classification, maybe A grade, B grade, C grade, any one grade possible from A to D like that. That depends on the application. The class vary. So now we will see case studies. I explained briefly now that formula how we are going to apply for various case studies. Let me explain. So first one is healthcare, how we are going to apply Nav. Not only Nav-based classifier, we can go for support vector mission, you can go for decision tree, or you can go for SVM, or you can go for neural networks, or you can go for advanced neural networks. So depends on. But here I'm going to apply a Nav-based classifier because I have explained briefly about this classifier. So that's why it is comfortable for you to understand also. So in general, whenever if you visit a doctor, so doctor is to collect symptoms. So like a fever, a headache, a stomach pain, etc. So based on that symptoms, the doctor will decide you have a this disease, X disease, or Y disease like that. So the table also looks like this here. We have patient one and symptoms are like this: headache, ear fall. Patient two and the symptoms also available. And obviously the class also available displayed here. The class means final output or maybe label we can call it as it. So first data that is called for patient one, the class is negative, for patient two positive like that. So whenever new patient visited, then we have to collect his features or symptoms. Then we can say directly. So you have COVID for negative or third stage, or maybe COVID positive first stage. Like that, you will make a conclusion and you will inform to the patient, and based on that, you can go for further diagnosis. So this is the new data. So the active patient, we can call it as a new patient. So chest pain, dry cough, etc. This is the data available we have. This is synthetic data set I created based on the various sources for better understanding. But nowadays it's difficult to get this data set directly. But if anyone is there, you can prepare accordingly, or maybe you can prepare class notes also. So here what we have to do, I already explained this one. We have to find probability of positive based on all the symptoms. So 0.16 is the probability, and we have to find the probability of negative class, and based on all the symptoms, here we got 0. Finally, which is the maximum 0.16, which maximum belongs to which class? Positive. Therefore, we can go for classification positive. So we can call it as argmax. Argmax means maximum marks corresponding to which class. So that is called argmax. So C1 is the that means positive is the output. Whatever data we have received from the patient, so based on that we can make a conclusion he is having COVID positive. Then immediately we'll go for diagnosis. If COVID negative means no need to go for further diagnosis. He can leave the campus. That means hospital. But if we have a COVID positive probability is more than negative, then we have to visit the concerned person, and based on that they will provide help for them. So finally here, because of 0.16 is the highest probability, that's why that is first class. C1 is nothing but positive, what we are assuming in the previous slides. So therefore, finally we can classify the given patient having COVID positive, and immediately we'll go for further diagnosis. Here also same thing we can apply. So we have a symptoms. Let us assume x1, x2, x3. We have three symptoms, and the label is by there is flu, whether the person having flu or not. So that is the concept here. So we have various values of headache, runny nose, etc., and flu also, yes or no. If any new patient visited is having symptoms like this, headache, and runny nose, yes, and maybe fever is no, then obviously you will get output is a no. So whatever data we have received new data from the patient, so based on that we can find the probabilities. Highest probability corresponding class is nothing but finally graduated with the highest score in the MBU. Like that we can make a conclusion. So that means so foster data is very very important for this machine learning. So this a new person having headache. This is the test data. Training data is this one. First one, last table is test data. So test data, we have symptoms, yes or no. So headache, yes. Runny nose, no. Fever, no. So by observation, maybe you will get negative results only. What we have to do, we have to find the probability for both negative and positive. So after calculating flu negative 0.03 and flu positive, we got 0.06. Out of this, maximum value is 0.0741, and we can classify yes only flu, the person having flu like. So this is a simple case study how we are going to apply Bayesian classify for the given data. Based on that, we can go for classification. Of course, we have various other symptoms. If we have, then we can include. Just for understanding, I included only three symptoms: X1, X2, X3. If you have more, we can include accordingly. Now, one more very, very important one is case studies, that is called recommendation system. So we are being influenced with this recommendation system every day, not only every day, every minute. Because whenever if you open mobile, you'll get recommendation of the friends, recommendation of the movies, recommendation of the some XYZ. So that's why machine learning plays a very, very vital role. Basically, the idea beyond this recommendation system is, so this is the data set, and my interest is this one. Let us assume movie day. These are the movies, that is called movie data set, and my interest is, let us assume, comedy movie. So what basically recommendation system will do, it will recommend the movies which I'm showing interest, and it will filter which I'm not showing interest. So filtered, these are the movies I'm not showing interest. I'm showing interest for this movie, that is called comedy movie, let us assume. So then it will recommend to the customer or user. So then whether user going to watch or not, that is left to the user or customer. So this is a basically recommendation system idea. That is called it is a basically information filtering system. It will filter the movies which I'm not showing interest, and it will recommend the movie which I'm showing interest. So this is the recommendation system definition, and how machine learning comes to the picture, that we will see. We have huge number of applications of recommendation system, as you can see here. Streaming services, Netflix, YouTube, Amazon, etc. E-commerce like eBay, Amazon website, etc. Like mobiles, all those things we are giving order through e-commerce websites only. Healthcare applications and finance, agriculture sector, social media like LinkedIn, Facebook, etc., Twitter, etc., and e-government, library, tourism, hotels, almost all the sectors or all the fields, the recommendation system will help for the recommendation of the things to the customers or users. So most of the enterprise applications they are going to automate by 2025. In that, recommendation system plays a very, very vital role, because without searching we'll get recommendation. Suppose I'm staying in Whitefield, without searching I'll get recommendation of the good hotel, or maybe I'll get recommendation of the good hospital for a diagnosis of some XYZ disease, like that. So that's why recommendation system is very, very important application. Those who are interesting on this topic, we can start research also, because there is a high possibility for acceptance because of huge number of applications, and it's very, very interesting also. That is also one point here. So we have various types of recommendations: popular based, content based, collaborative filtering. And popularity based means more trending video. For example, 2 days back, IPL match final completed. After completion of the match, we used to receive directly IPL 2023 final match highlights without searching. Directly we are getting recommendation. Why? Means that is the most popular trending video. Because of that reason, whenever we have a most popular trending video or music, whatever it may be, you will get automatically recommendation without the help of any other models. That is called popularity based recommendation, that is based on the more trending and popular among the users. What is content based? What is collaborative filtering? So in collaborative filtering, we are going to focus for one case study on collaborative filtering by using machine learning models. In collaborative filtering, what basically how it will work. So we have two users, both watched the movies. Let us assume Crack and KGF. Suppose the what it indicates, both users are similar. A and B are similar because both watched the movies Crack and KGF, which indicates that both are having maybe what type of movies these are all. I think mass movies. What we can call it as mass movies here. Maybe action movies, let us assume. Yeah, action movies. So both liked the action movies. That is the meaning here, because both watched the Crack and KGF means understood that both liked the action movie. Suppose one new movie released here, let us assume Bahubali. She watched this movie, then according to the recommendation system concept, because previously they have high correlation of the similarity, because of that reason, whatever movie watched by her, it will recommend to directly to the other user. So that means whatever movie watched by her, let us assume user A, that movie will recommend to B. Suppose B watched the movie, let us assume what is the latest sensational movie, some movie, let us assume Kantara. So B watched the movie Kantara, so or maybe any other movie you watched the, then automatically this movie will recommend to A. So this is the basic idea beyond this collaborative filtering process. There we are looking for similarity between users. And content based means we are looking for past activity. So this user used to watch movie one, movie two, both are comedy categories. Suppose today some other movies are released in the market like movie 3, movie 4, movie 5. Out of 5 movies, so comedy movie will recommend to the user, because based on the past activity, historical data. What is the past activity? Or when you see the past profile of the user, you used to watch only comedy movies. Because of that reason, whatever other movies released in the what we can call it as a streaming services, or maybe Amazon OTT platform, movie 4 only will recommend to the user. Why it will recommend movie 4? Because based on the profile, so he likes more comedy movies. Because of that reason, movie 4 will be recommended to customer. Whether he is going to watch or not, that is left to the customer. But as a basic idea beyond this recommendation, so the recommendation system will recommend movies to the customer based on the interest. So this is called content-based filtering algorithm. Now, when you come to this side, yeah. Now I'll come to the case study. We have a user item matrix. Whenever if you watch movies, we used to give a rating system, and let us assume when you convert it into utility matrix, or we can call it as user item matrix. User one, if you take here user one, item one, rating given 5. Similarly, user two, rating one. So somewhere here, rating 4, user 2, item 2, rating 4. He already provided rating for some of the items not provided. That means not provided means, so he did not buy that item. That's the meaning. Now, what we have to do, we have to find the rating prediction. So here I'm taking rating scale is 1 to 5. We have to find the rating prediction. based on that rating prediction, we can go for recommendation of the items or movies or products to the customers. How to find rating prediction? Their machine learning comes to the picture. We have to apply Bayesian classifier or decision tree or any other algorithms, or maybe any similarity measures like Pearson correlation coefficient or cosine similarity, etc. By using that, we can go for recommendation of the items or movies to the customer. Now, our basic idea is we have to find the rating prediction. Wherever empty cells are available in this matrix, that empty cells data value we have to find. Based on that, we can go for classification. If the prediction is like 100, 200, let us assume less amount, then it's very difficult to go for. So always rating should be very high for recommendation. Low rating means no need to recommend. How the machine learning comes to the picture means we have to find probability for all the ratings, because rating scale is 1 to 5 we are assuming. So we have to find probability for rating 1, rating 2 given based on the previous rating. Here X is nothing but previous ratings given by the same user. So and rating 5, all the ratings we have to find. Out of 5 ratings, what is the maximum probability? For example, rating 5 probability is 0.7, which is the highest probability when compared to other ratings. So then obviously this movie, let us as a movie 4 is going to recommend. So depends on, so we have to find the maximum probability, and based on that we can go for rating prediction, hence we can go for recommendation. So this is the basic idea by using Bayesian classifier, or you can go for any other similarity measures also. By using that we can go for recommendation of the movies. As you can see here, so let us assume I have to find the rating prediction. Based on that we can decide whether the movie is going to recommend to the. So rating 1 probability is 0.2, rating 2 probability is 0, rating 3 probability is 0.4. Is you can see here, rating 4 probability is 0.1, rating 5 probability is 0.3. Out of this, what is the maximum probability? 0.4. 0.4 corresponding to which rating? 3. So therefore, final rating prediction is that is called argmax. Maximum is 0.4. Argmax means the maximum value corresponding to which rating? 3. Therefore, the rating prediction is nothing but 3. Now, the system will decide, recommendation system will decide whether the movie or product is going to recommend. In general, minimum rating should be 4. So if the rating prediction is 4 or 5, then automatically the movies or maybe product are going to recommend. If the movie rating is like 1 to 1.5 means it is not going to recommend to the customer or user. So this is the way machine learning comes to the picture. Not only based in classifier, you can apply decision tree or random forest or SVM or any KNN clustering algorithms also you can apply. But just I have given basic idea how it will work by using machine learning models, but you can apply any other models also for that classification of the rating. So this is comes under categorical classification because ratings are 1 to 5. Suppose if you have rating scale is 1 to 10, then what we have to do? We have to find other ratings also. Probability of rating 6, probability of rating 7, 8, 9, 10. So all the ratings we have to find from 1 to 10. Out of that, maximum rating, so for example, maximum rating is corresponding to 9. Then 9 is the rating prediction. 9 rating prediction out of 10 means it's very, very good. Then hence the movie is going to recommend to the user. Then he can, she can go and watch. So this is similar to previous one. I will skip this one. Even here we have for healthcare applications recommendation of the prescription I have already told you. So these are the patients already exist that we can call it as a past data or historical data, and we have symptoms or we can call it as attributes: age, insulin level, glucose level, BMI, body mass index, BP, blood pressure, and thickness. So that is called pack level. Now 4 patients are available in the data set. One new patient, we can call it as active patient. So we have collected the data: age, insulin level, glucose, etc. Now which prescription we are going to recommend? We have already 4 patients prescription in the data set. Now which patient prescription we are going to recommend? For that, machine learning comes to the picture. What we have to do is we have to look for a similarity between patient Tom to patient 1, Tom to patient 2, Tom to patient 3, Tom to patient 4. Out of these 4, we can look for maximum probability, maximum similarity. Based on that, we can go for recommendation of the prescription. Now you can see here, so similarity between Tom and patient 1. For finding similarity, we can go for cosine similarity measure, or we can apply Pearson correlation coefficient. Based on that, we can find the similarity measure. So here similarity between Tom and patient 1, 86%, and similarity between Tom and patient 2, 0.5. Tom is fixed here. So we are looking for who is which patient or who is very close to Tom. So for that, we have to look for similarity between, that means correlation between Tom to other patients. So, and patient 3 is 0.49, and patient 4 0.04, and for other patients not available, only 4 patients. Out of this, maximum probability is 0.86. That means there is a high correlation between Tom and patient 1. Hence, whatever prescription provided to patient 1, that we can recommend to Tom. So that is the final conclusion. Why we have to recommend prescription of patient 1 to Tom? There is a high similarity when compared to other patient. Because of that reason, whatever prescription provided by doctor to the patient, then prescription is going to recommend to the active patient. Who is active patient here? Tom. So this is the way the recommendation system will work for healthcare industry, also for recommendation of the drugs, or we can call it as a medicines. You can see the final conclusion. So the drugs prescribed by this patient can be recommended to Tom. So that means patient 1. So this is the way it will recommend. So patient 1 data, we have same thing, copy paste here, because drug 1, I mean patient 1 is prescription is going to recommend to Tom. Only patient name is Tom. Rest of the data is same, technical data, not date of birth, address. That is obviously different. I'm talking about what type of capsules or what type of tonic he has to take. All those things written clearly. So based on that, you can go for further treatment after the diagnosis. So here also we have to type some symptoms here. Based on that, it will recommend automatically the specialist or doctor. Depends on the disease. Suppose if I type malaria, dengue, etc., then accordingly you will get recommendation of the doctor near to your area, not like a long distance. Or maybe if you have something else. So depends on the symptoms. So it will recommend automatically to the doctor. Now, email spam filtering. Here also same concept. Whatever concept we have applied previously, we have to find the probability of spam given a future vector x. Probability of ham, that is called not spam, given x. Okay. X is nothing but the keywords of the mail. So this probability spam is, let us assume, zero point 0.7. This is 0.2. Then highest probability is 0.7. Hence, whatever mail we have received, it will go to the spam folder. That is the meaning here. So whatever mail we have received, it will go to the spam folder. So in second one, probability is less. That's why this is not going to consider as a not spam. Suppose here instead of 0.7, the probability is 0.3. Here the probability is 0.6. Then 0.6 is more than 0.3. Hence the mail is goes to the not spam folder, inbox folder. So the same classifier what we have applied previously, that we can consider for classification of the mail, whether spam or not spam. Here also this is one spam folder, so it will go automatically based. So this is the spam collection data set. If you are looking for this, you can go to the Kaggle or maybe UCI machine learning repository. So here you can see here, so probability of spam is more than probability of not spam, and whatever data we have tested, new mail, it will go classified as a spam mail. Hello, madam. Hello.
Oh, yes, sir. Some questions here.
Yeah, yeah, I'll come back, madam. So
Okay, so some
time up,
participants are.
time up now, madam.
Okay, okay, it's okay, sir. No problem. Okay,
So
some.
yeah, we have few
Oh,
more that maybe we'll see in other session, because still we have so many other people also. Because
okay, sir. Some participants asking some questions.
I'll come back to you that, madam.
Okay, okay, okay.
Yeah. So this is the way we can go for classification of the mail. And similarly, we have intrusion detection system for cyber security. This we will see later, because these are also very, very important. This is called machine learning for cyber security application. And we have regression models for prediction classification, that also we'll discuss, like rain, weather forecasting, or country GDP prediction, or maybe coronavirus number of cases prediction, etc. We can do. And research directions also I'll explain. So it will take a lot of time to explain all those things. I have explained few case studies for machine learning, and if you are looking for further enhancement of this machine learning, you can go through these textbooks: machine learning for cyber security and mathematics for machine learning. Because without mathematics, we can't understand machine learning. That's why mathematics is very, very important. And this is the website. There we can find the data sets, that is called UCI machine learning repository, or you can use Kaggle or GitHub public repositories also fine. There also you can find the data sets. So if you have any questions, ask me. That was my talk on briefly about machine learning and case studies. So if you have any questions, you can post in the chat box. I'm happy to answer. Yeah, tell me,
Okay,
madam.
sir. Okay, so first question is what are the different types of machine learning? Somebody asking that like that.
Yeah, yeah. So I have already explained in the past. We have supervised machine learning, unsupervised, semi-supervised, reinforcements. Like that, we have various types. So we focused on supervised machine learning. Supervised means labeled data. Yeah, I gave so many examples also. Unlabeled data means we don't have any output, but still we are looking for classification based on the maybe futures, or maybe based on the some other criteria we have to consider, like clusters. We have to make a clusters. Based on that, we can go for classification. And unsupervised, we have what we can call it as a clustering comes under unsupervised learning, and associated rule mining comes under cluster. I mean unsupervised learning. All those things comes under unsupervised. It's also a very huge topic actually.
Okay, what advancements can be made in the use of machine learning explainability techniques to provide insights into the decision making process of email spam filtering systems?
Yeah. So in email spam filtering, I have shown here. Just I will show now. Yeah. So in general, you can see this is my actual spam email. As you can see here, what are the keywords we can find? So Black Friday and winners and a special gift. So this type of keywords, whenever if you find that, most of the mails will go to the spam folder. So that means the classification is happening because of this type of buzzwords. So gift to surprise, bumper prize, bumper offer, or you can see this is the data set. You can see one example here. Let us assume spam mail winner, that is also one. A valued network customer, you have selected receive and price reward, claim. This type of keywords, if you find, that machine learning model automatically will classify as a spam. Otherwise it will go to the not spam folder. But we can apply any machine learning models, but based on the accuracy, we have evaluation measures also. That is very, very important. So whichever algorithm giving more accuracy, that we can finally deploy to the application. Because I have explained Bayesian classifier, but still we have so many other algorithms. So whichever model is going to give highest accuracy, that we can deploy to the application.
Okay, what are the challenges and opportunities in applying content-based filtering to diverse the domains such as music, movies,
Yeah,
and
yeah.
books, fashion, or health-related content?
Yeah. Actually, content-based filtering, we have challenges that is called cold start problem. So here I'll write the word that is called. I will write what is the meaning. I'll tell you. So COLD. Of course, there is a huge research is going on this problem, cold start problem. What is the cold start problem? Is suppose a user not having any profile, and in what basis it will recommend? Because as I mentioned clearly, one second, one second. Hello, madam. I'll come and meet you, madam. 5 minutes. Okay, fine, madam. Thank you. Thank you. So what does it mean cold start problem? Whenever a user having not active profile, just join, then in what basis will recommend the movies? Because in content-based filtering, based on the user profile or user activity, it will recommend. So that is the problem here. So this problem still people are doing research. Maybe they'll come to the solution properly. But still something is happening on this content-based filtering with some less accuracy.
Can content-based filtering be applied beyond traditional recommendation systems such as personalized content discovery in news articles, online learning platforms, or e-commerce product search?
Yeah, we can apply. That's why I mentioned e-commerce also. For example, I'll give one example. I used to give always order C. So far, I have given order for C, C++, Java programming. Suppose today some new programming language textbook, let us assume Python or R program released in the market, then automatically it will recommend to me, because based on the past activity, always I used to give programming languages textbooks, then I will get recommendation. So obviously, e-commerce websites is one of the powerful recommendation search engine. Even if you take streaming services also, even when you take movie watching in OTT platform, etc.
Okay. What are the potential future directions or improvements that can be explored based on the insights gained from the case study?
Not getting, madam, this one.
So, what are the potential future directions or improvements that
Yeah,
can
yeah.
be
Yeah,
explored?
that's why I told now just a cold start problem. This type of issues we have, we can go. You can take it as a research topic, and you can find out some solution for that. Based on that, maybe we can publish paper or we can go for patent. So each model having some pros and cons. So based on that, we can choose and we can go for some better enhancement. When you increase accuracy, obviously we can go for some new models also.
Okay, what was the specific business problem or a challenge addressed in the case study, and how did machine learning help in solving it?
Business problems, all this e-commerce what we have explained a minute, that comes under business models only, e-commerce websites, all those things. Even tourism, even when you take finance or banking sector, everywhere we have this recommendation system. Even we have machine learning models for applications of these things. I
Okay, how
listed actually in recommendation system, I have listed all the application enterprise applications. So there even banking sector, insurance sector, everything comes under that.
okay, how has machine learning have been applied in digital marketing to enhance the customer segmentation and personalized targeting?
Yeah, that I already explained, madam. Digital marketing, customer
Okay, that same
recommendation.
like okay.
Yeah, same thing.
Okay, how is machine learning being utilized in recommendation engines to personalize the product and content suggestions for online users?
Uh, can you read it, madam?
How is machine learning being utilized in recommendation engines to personalize product or content suggestions for online users?
No, actually, it won't ask any suggestion. Just it will recommend. The recommendation system basic idea is based on the user rating or based on the user activity. Just it will recommend, but it won't take any suggestion from the customers. Maybe we can put comments. Maybe that also may be considered in future. Based on the comments, maybe they'll go for improvement of the system, etc.
Okay, so I think question is that's all.
Yeah, yeah. Thank
So
you.
the answer is very useful. I hope the access that the participants can understand about that.
Okay, thank you. Thank you, all the
Okay, sir.
participants.
Okay,
Very
sir.
nice
Okay.
questions, all the questions.
Okay. First and foremost, I would like to express our deepest appreciation to our esteemed guest speaker, Dr. J. Somasekar. Your expertise, insights, and engaging presentations have left a lasting impact on all of us. Your willingness to share your knowledge and experience in the field of machine learning has been invaluable to our participants. I would like to thank all the participants who joined us today. Your active participation, enthusiasm, and thoughtful questions have made this session truly interactive and enriching. Your presence has contributed to the vibrant atmosphere and fruitful discussions that we have witnessed throughout the session. Once again, thank you each and every one of you for being a part of this session. Your presence and contributions have made it a truly memorable and impactful experience. We hope that the insights gained from this session will inspire and empower you in your future endeavors in the field of machine learning. So, thank you all and have a wonderful day ahead.
Yeah, thank you, madam. Can I leave, madam?
Hi, okay, sir. Thank you, sir.
Thank you. Thank you.